I think it's really important when we're dealing with fractions that we think really carefully at the outset about how best to obtain a solution. And I'm going to illustrate this by imagining that one of the questions in the maths exam is for students to work out 1/2 plus 1/5. Now it's very tempting for some students just to add together the top numbers, the numerators, and then to add together the bottom numbers, the denominators, and get the incorrect answer, which they would say would be 2/7. So it's definitely not 2/7. Perhaps the best way to look at this is to imagine that I place £20 on the table, and then I place $50 on the table, and ask how much money is there altogether when I combine £20 and $50. Clearly we have to get a common exchange rate. We have to know how many dollars equals how many pounds, and then we can proceed. And adding fractions proceeds in a very similar manner. So what I need to do here, before I even begin to make any progress, is I need to get a common denominator. And I'm looking for the smallest number that 2 and 5 will fit into. If I imagine my 2 times table, perhaps even writing down the 2 times table, and then the 5 times table, and I'm looking for the first number that appears in both lists, we'll quickly see that the answer is 10. So what I need to do when I'm adding 1/2 plus 1/5 is I need to make each fraction the same bottom number, the same denominator, and in this case I'm going to change these into tenths. Now I have to proceed really carefully here, because if I take my 1/2 and I've got to change it into tenths, I ask myself, what's the multiplier, or how many times bigger do I need to make the 2 for it to become 10? And I can see that the 2 has become 5 times bigger. And in classical Greek civilization, the Greeks came up with a golden rule of fractions. They call it the golden rule. And it basically said that a fraction remains unchanged when we multiply or divide the numerator and denominator by the same number. So effectively, whatever I do to the bottom part of the fraction, I need to do to the top. So if the bottom part, the denominator, becomes 5 times bigger, the top has to become 5 times bigger. So intuitively, that becomes 5/10. So I've made my first bit of progress by saying that 1/2 is equal to 5/10. When I consider my 5th, I've got to change my 5th into tenths also. I can see that the multiplier, going from 5 to 10, is times 2. So I've got to do exactly the same to the numerator, the top part. I've got to times that by 2. And so I can see that 1/5 is actually equal to 2/10. So I'm now going to re-represent the 5th as 2/10. Suddenly, adding fractions becomes really, really straightforward, because I've got 5/10 added to 2/10. So I can see that my overall answer is 7/10. So if we were asked to add together 1/2 plus 1/5 without the use of a calculator, the strategy is to get a common denominator. In this case it was 10, and my overall answer is that 1/2 plus 1/5 is equal to 7/10. The good news with regards to subtracting fractions is that the process works in a really, really similar way, virtually identical apart from the last line. So if I've got to work out 1/3, take away 1/4, I establish the fact that the smallest number that's in the 3 times table, the 4 times table, is 12. So I'm going to change both fractions into 12ths. Now I can see, from a similar example to before, that the multiplier, going from 3 to 12, the bottom part has become 4 times bigger. So the top has got to become 4 times bigger to make it an equivalent fraction. So I can say that 1/3 is equal to 4/12, and similarly here, the 4 has become 12, so that's tripled. So I now need to triple the top part, so that now becomes 3/12. So 1/3 take away a quarter is just simply 4/12 take away 3/12. And I can see that my final answer, the last little bit was different to the previous example. I'm just going to subtract the numerators instead of adding them. So I end up with 4/12 take away 3/12, which is just 1/12. And 1/12 is my final answer. Now, when we multiply fractions together, we quickly establish the fact that multiplication of fractions is one of the easiest things in the whole wide world to do. All I have to do here is to, in this case, 2/3 times 4/5 is simply to multiply the numerators together. So 2 times 4 is 8. I multiply the denominators together. 3 times 5 is 15. And incredibly straightforward procedures produces 8 over 15. And I just double check that 8 over 15 can't be simplified. So there's no number apart from 1 that will go into 8 and into 15. So that fraction cannot be simplified. So 2/3 times 4/5 gives me 8/15, which is my final answer. When we come to divide fractions, in this example we're going to look at is 3/4 divided by 5/6. There is some more good news for all of us, because we never ever ever have to divide fractions. We just carry out a little trick in our maths paper where we flip or invert the second fraction. So we turn it upside down, and then we can change the divide sign to a times sign. So in this example, the 3/4 divided by 5/6, I just take my 3/4, I flip the 5 over 6, invert it so it becomes 6 over 5. And the really fantastic news is I just times those numbers together. So what I now need to do is to work out 3 times 6, which is 18, 4 times my 5, which is 20, and I get 18 over 20. I just double check to make sure that 18 over 20 is in its simplest form, and you can see that it's not quite there yet, because there is a number that goes into 18 and into 20, and that number is 2. So just to gain the maximum marks, I would divide 2 into 18, and I get 9. I divide 2 into 20, I get 10. So my overall answer is 9/10. So 3/4 divided by 5/6 is not that difficult. Just remember the key strategy is to invert or flip just the second fraction only, not both of them, just the second one, and change the divide sign to a times sign. And that produces 18 over 20, which simplifies to 9 over 10. So a little trick with division of fractions makes dividing fractions really, really straightforward. Now sometimes, in a maths exam, we may have to multiply or divide fractions that are produced in mixed numbers. So the example we're going to look at now is 1 2/3 multiplied by 2 4/5. Now, before we make any progress whatsoever, we have to do something significant to both of those fractions. In a way, we have to make mixed numbers, such as these, malleable. We have to change them into something else before we can do what we want to do with them. In order to make these fractions malleable, we actually need to change them into top-heavy fractions. Now, when I'm looking at 1 2/3, I want to really ultimately change that into a number over 3. So I want to change that to a top-heavy fraction here. And the little trick that we do is we multiply the whole number here, in this case 1, by the denominator. So I go 1 times 3, then I add the numerator, so I produce 5 there. So 1 2/3 is equal to 5/3. So just a little trick here, I multiply the whole number by the bottom number here, and then I add the top number, and that gives me the number of thirds. Similarly, the same trick to 2 4/5, I need to change that to a top-heavy fraction. So I go 2 times 5, which is 10, 10 plus 4, 14, so that gives me 14/5. So I've now got my fractions exactly where I want them, because I can then manoeuvre a situation where I can multiply fractions together to produce the desired result. Now some students can look at this diagonal here, and they can cancel the 5 here and the 5 here, Other students prefer not to cancel. It doesn't matter so long as you get to the desired answer. In this particular case, I'll just multiply the 5 by the 14 and I get 70. I multiply the 3 by the 5 and I get 15. And I know I have to simplify that. So I know that 5's will go into that and 5's will go into that. 5's into 70 goes 14. And 5's into 15 goes 3. So my overall answer is that 1 2/3 times 2 4/5 gives me 5/3 times 14/5. That then gives me 70 over 15, which gives me 14 over 3. The advantage of cancelling, if you wanted to cancel, in this case we could cancel the 5 here and the 5 here. 5 into 5 goes once, 5 into 5 goes once. That would give me 14/3 straight away without manoeuvring to 70 over 15. But it doesn't really matter. If you don't wish to cross cancel, then we can simplify the fraction at the end. But 14 over 3 is the correct answer. And finally, with our fraction arithmetic, we're going to look at a division problem involving mixed numbers. And we're going to look at 3 3/4 divided by 4 5/6. So again, I have to make each of these fractions malleable. I have to make them into top-heavy fractions in order to do what I want to do in the next stage. So, similar to the previous example, I'm going to work out 3 times 4, which is 12. 12 plus 3 is 15. So that's 15/4. And I'm dividing that. Well, 4 times 6 is 24. 24 plus 5 is 29. So I've now got 15 over 4 divided by 29 over 6. I remember the little trick for dividing of fractions. I just simply need to invert or flip the second fraction upside down and multiply. So this produces 15 over 4. Now, 29 over 6 becomes 6 over 29. And the divide sign becomes a times sign. So the little trick of just inverting or flipping the second fraction and multiplying gives us the desired outcome. I then think to myself, okay, 15 times 6, well I know that 2 15s are 30, so 4 15s are 60, so I've got 6 15s which are 90. On there. I know that 4 times 29, well 4 times 30 is 120, so that's going to be 116. And then I can just proceed to simplify this fraction. We could divide each of our fractions by 2 here. So I've got 45 on the top here. And then if I divide 116 by 2, I get 58. So my overall answer for 3 3/4 divided by 4 5/6 is 45 over 58. And my strategy was to simply manoeuvre a situation so that I ended up with top-heavy fractions first, flip the second one and multiply, simplify my fraction, and I get the full marks with my final answer. So if you manoeuvre through, work through carefully with these questions, and make sure that the mixed number becomes a top-heavy fraction, it should be no problem in getting full marks. So best of luck for this question from the Collins team.